There's one more method to solve a system, and it's the method that we're going to look at today, which is called elimination. Go through the steps with me. If it sounds like gibberish, just follow along, and then hopefully when we get to an example, it'll all come together. Step 1 may or may not be necessary. It's to multiply one or both equations by a constant, which we know just means a number. So at least one pair of like terms has opposite coefficients. Then what you do is you add the equations to eliminate one of the variables, and then you solve what's left. The last step is to substitute the value that you got from the last step into one of the original equations and solve for the other variable. So here's what that all means. Scroll down to example 1 with me. In example 1, let's look at the coefficients. Remember, coefficients are the numbers in front of their variables. So we've got a 3 and a 3. Those are very close. They're not opposites, but we have a positive 2 and a negative 2. Those coefficients are opposites. So what I'm going to do is skip step 1 because I already have opposite coefficients. Step 1 says if you don't have opposite coefficients, then you have to multiply, which we're going to look at in the next example. But I can just shortcut straight to step 2, which is to add them. So what I do is I add them, and I go like this. 3x plus 3x is 6x. 2y plus negative 2y cancels each other out. That is the goal of the elimination technique, is that it's to get a variable to go away, so you only have one variable left. Now I just go to the numbers. 4 plus negative 4 is 0. So that's pretty obvious. I don't need to really divide by 6, but I can show it if you want me to. X is 0. Now remember, that's only half the answer. So I only know the x value of the intersection point. I still have to get, oops, sorry, that was a 6. I still have to get the y value. So what I do is I take this 0, and I pick one of my original equations, whichever one looks easier. I'll take the first one because it has positive numbers, and anywhere you see an x, you put a 0. So let's do 3 times 0 plus 2y equals 4. So that gives me 0 plus 2y equals 4. I can tell right now y is going to be 2. So that goes right up here. So the intersection point is 0, 2. You could take 0, plug it into the other equation, and that's how you could confirm that 2 is the correct y value. All right, let's move on to example 2. If you look at your coefficients, we've got a negative 10 and a negative 5, and those are obviously not opposites. Then you have a 3 and a negative 6, and those are also not opposites. So this would be an example of where we have to do step 1, which is multiply by something to make them opposites. Now, the something is figured out by you looking and going, how can I make these numbers opposites? So let's look at negative 10 and negative 5. And let's think to ourselves, how could I make them opposite numbers? Well, if you multiply negative 5 by negative 2, then this would turn into a negative 10, which would be the opposite. You could also go to the y's. How do you turn a 3 and a negative 6 into opposites? If you multiply 3 by 2, then that would turn into a 6, and then that would be opposites. So it's up to you. You don't do both, but you pick whichever one looks friendlier to you, and you multiply by that number. So I'm going to multiply the top equation by 2, and I like to put parentheses around it. It helps to remind me to distribute. So I'm going to multiply, and I'm going to get negative 20x plus 6y equals 2. Then you just bring over that other equation, negative 5x minus 6y equals 23, and you add. So now we add. Negative 20 plus negative 5 is negative 25. Negative 6 plus positive 6 cancels each other out, and that was the point. And then 2 plus 23 is 25. That is super friendly. I can tell that x is going to be -1. And remember, that's only half the answer. I still have to plug it in to one of the original equations. I'm going to pick the bottom one. So I'm going to take it and I'm going to plug in -1 in spot for x. So -5 times -1 minus 6y equals 23. That gives me 5 minus 6y. Then I will subtract 5 and divide by -6. And you get y equals -3. So that goes over here into the answer. And the other way to confirm that you have the correct answer is to take -1 and plug it into the other equation. Alright, let's wrap this up with a word problem. Pause the video, read the story, and press play when you're ready to move on. Alright, so I've underlined the important information, and again, because we're newbies at this, it gave us the setup of what we need to do. What they didn't do is define their variables. So let's define our variables. Let's say that x will be the large, so x is the cost of large, and y will be the cost of the small. So now I can just go and write my equations based on the setup that they gave me. 5x plus 2y equals 235,000. And 2x plus 3y is equal to 160,000. Now I have to figure out how to multiply to make them opposites. So 5 and 2, that's not really helpful. And a 2 and a 3 is also not. So what I'm actually going to have to do is part of step 1 said you might have to multiply both equations. So you can either turn these two numbers into tens by multiplying, or you can turn these into sixes. I usually like to go with the smaller number, so I'm going to multiply this top equation by -3. And this bottom equation by 2, and then I'll turn the top one into a -6, and the bottom will turn into a +6. So let's rewrite our equation. So the first one is going to be -15x minus 6y. Definitely need a calculator for that. 235,000 times 3. So that's -705,000. And then the bottom equation becomes 4x plus 6y equals 160,000 times 2. Oh, duh, that's 320,000. So now we add, and I get -11x. Those cancel. That was the point. And -705 plus 320 is -385,000. Divide that by -11, and I get that a large van costs $35,000. That's expensive. All right. Now I have to figure out the cost of the small van. So I'll use the bottom equation. 2 times 35,000 plus 3y equals 160,000. So that's 70,000 plus 3y. Subtract 70,000. Sorry, I had to get my calculator out. That's 90,000. And so that means that each small van is 30,000. So now we go back up to the question, and it says, what is the total cost for each type of van? So let's write our sentence answer. Large van Large vans cost $35,000 each, and small vans cost $30,000 each. If you have any questions, write them down and ask me when you come to class.